Right, thank you. So this is a train the trainer video for introduction to application security, a DevNet lab. So in this lab, we're going to discuss, first of all, our cloud protection suite. What does it have, and some of the components, which includes a secure workload and Panoptica. And then we have hands-on labs for both of these products. And at the end, we're going to share some resources. So you can start by talking about our cloud protection suite. And so that covers both of these products, right? And that ties them pretty well together. So Cloud Protection Suite has all the capabilities that's required to work with any type of workload, to secure any type of workload. So bare metal, VM, containers, and serverless. And within the suite, we have a couple of solutions, right? So including multi-cloud defense that protects all of the multi-cloud, right? So all of the AWS, Azure, Google, Oracle, and we have workload security, which is basically our secure workload. And we also have a full CNAPP solution, our application security cloud, that's also known as Panoptica. Adding on top of that, we also have our vulnerability management, which is Kenna, and attack surface management, which is basically Jupyter 1. But we're going to focus on secure workload and Panoptica, and working to add more lab modules so that we can pretty much cover all the cloud protection suite, at least multi-cloud defense, right? But we'll start with our workload security here, which is a secure workload. It is has been a solution for quite a while. It started as a appliance solution that customer hosts on their own premises, but then it became a SaaS solution. So what it does is it can work with all type of workloads from on-premise to cloud, all sorts of clouds as well, and also physical devices to VMs to containers. And it provides this framework that can help to analyze, leveraging AI to analyze how does these API, how does these different workloads talk to one another, and it can suggest what is the best policy to properly apply a zero trust, or let's say least privilege access for these workloads, so that we can keep them working, but you don't have to allow too much access, right? And that is because when we talk about applications, they got a lot of different components and they have different communication as well. So user access the different pieces of these applications. But then there's also application to application communication, which includes within the same application, which what we call internal, or there could be some additional API calls to the outside. Maybe we're leveraging a service like Google Map, right? Or there's application to application communication that's external to the application itself. So how do we identify all of these, right? Because when we need to secure these applications, we need to see it as the bad guys, right? So how does the bad guys work? So what they try to do is, of course, they want to get a foot in the door, right? So that's the initial access. And then what they do then is they will see, so that usually, leveraging maybe a vulnerability or open port, or maybe too much access that we grant to users or some other applications, right? And then when they get a foot in the door, they will do lateral movement and try to pivot into your critical systems, like maybe databases or maybe Active Directory, or all of those different components, and they will try to see what is important, right? And then the goal is, of course, to get as much information as possible, right? And as much control as possible through like privilege escalation, right? And then I'm gonna get all of that good information, and I'm gonna exfiltrate them out of your application, and I'm gonna maybe hold it as ransom, right? So this is how the bad guys work, and then we need to see how do we limit their access, right? So maybe we still have vulnerabilities, but how do we make sure that we don't expose them, or how do we identify those vulnerabilities to begin with, right? And then we need to control the access down to bare minimum, so that they can't easily pivot in our environments, to control that lateral movement. Of course, um, so all of these threats are getting more and more complex, right? So being able to understand these threats from a minor attack framework really helps, so that we know, what are the tactics and techniques that the bad guys are leveraging to get in, and so we can see how do we block them. So I usually do some demos here, but it depends on the time, because this is just a 10 minutes overview. So maybe we don't do the demo, but you can do that while the lab is happening as well. But that demo is also available as part of the lab. So I actually have built in the demo video in the lab. I'll show you in a second, so so the attendees can watch that afterwards as well. But overall, the secure workflow provides this zero trust segmentation and also visibility to the application. So you can define policies that block certain access based on either vulnerabilities that we identify or some of the rules that you define, that says, hey, maybe not all the applications need to access my PCI database, right? So you can use that to to block some of access. But on top of that, secure workload is a whitelist based approach solution. So basically, you allow by default, right? So you allow all the connections to happen, and then the rest of the connections are by default blocked unless you allow that, right? So that provides that zero trust and least privilege access among within or among the applications. So that's essentially how it works in a nutshell. But it also utilizes AI, to build the dependency map, right? So that you don't have to do all that work yourself. By listening to all the conversations within and across applications, secure workload can tell you these are the connections that need to happen for this application to work. And then, of course, you can adjust on top of this, right? So when you can click on each of those lines that tell you what exact communication that is, right? So the all the ports and protocols and the priority and the action, whether allow or not. And then you can adjust on top of this. You can just drag and drop and allow additional access if you need to, right? And after that's done, you can lock it down to only these connections are allowed, right? So it's very easy for an administrator to understand how it works. But ICE also provides additional context because it can be an agent-based solution. So we can deploy agents into these workloads and see what are the processes that are running, what are the vulnerabilities, and if there's a privilege escalation, we can identify that right there. And if there's any forensic events, we can call all of that out, and administrators can see all of these on the dashboard, right? So with that said, I'll pivot to our APIs because secure workload also have a very robust open API. And it's pretty much all the capabilities that we see, can be accessed on the API, including managing all of these agents we call sensors, right? And the inventory, user role, and defining the scope of the application and the policy of the applications, and also external integrations, right? And automate a lot of the different processes. And we can leverage multiple tools like Python, we're going to leverage today. You can also use Ansible, Terraform. So lots of different ways to interact with secure workload. And then secure workload can also integrate with a lot of different solutions like secure firewall to establish this, agentless approach, right? So maybe secure workload can provide all the context to firewalls, and we can leverage the firewalls to then block some connections. Or integrate with F5, for load balancing or security of the applications. So, a lot of integrations and automation we can do. And today in this lab, we're going to leverage a Python client, SDK, if you will, to interact with our secure workload. So Now you can decide, after presenting on the secure workload, you can pivot into the secure workload lab, or you can finish the presentation on Panoptica and go to the lab. The two labs are actually can be accessed through one link. So this is the secure workload portion. And I'll quickly pivot into Panoptica to introduce the differences and what additional value Panoptica brings to the table. So Panoptica is our CNAPP solution, is our for cloud native application protection. And when it talks to, when we talk about cloud native, it's really a modern application, form of a modern application, and it has a lot of different components, right? It actually looks like this: a lot of different containers that are connected by API calls, and a lot of things could go wrong in these environments, right? Because there are a lot of benefits. I have some hidden slides that talk about benefits if you have a longer session. Right, like these applications can just scale, and you can deal with any kind of outages without sacrificing users' experience. But on top of that, there are challenges that these cloud native applications brings, is because we are dramatically increasing the attack surface. And with that said, so these attack surface could come from anywhere, right? Either from within the application itself, maybe through API calls, or maybe through some open source components, or maybe databases or some messaging queues. So a lot of things could go wrong. So that is why if you overlook some of these components, let's say, for example, APIs, so there are so many different breaches that could happen, right? So like LinkedIn and Twitter, they had some pretty extensive data exposure, all because of API were not properly designed, or not secure. So I can register as a user, and maybe I can access other users' objects, so that maybe I can steal their account credential, or maybe I can steal their content, in their accounts. And there are so many other different ways that we can attack APIs, like broken function level authentication, and and vulnerabilities, right, or exposed S3 buckets, and all that stuff. We have to have a way to see all of those exposures, and that's what Panoptica has, that unique capability to do that. And also, it can help us see all the different components of our application through software bill of material, and it's kind of like ingredient for our food, right? So I always use that example, like maybe I'm allergic to certain food, so I need to look, what is the component of that food, so I can see whether I can eat it or not. So software bill of material is very similar. It can give you the vulnerabilities and authors and versions, dependencies of those different software components, so whether there's potential malicious, and we drill down, like peeling the onion, to see all the dependencies and whether they have any uh, uh, vulnerabilities as well. So at the end, you will see all the different vulnerabilities, right? So throughout this lab, you'll be able to deploy an application, and also use Panoptica to secure that application as well. So that's why we're introducing our CNAPP solution. So by Gartner's definition, we need to be able to secure any of the cloud native application by looking at software bill of material and identifying all the vulnerabilities, but also be able to protect the runtime, by securing the API calls, and also protect any sort of workload, right? Like VMs and containers and serverless functions, and be able to secure the cloud altogether. So Panoptica provides all of these capabilities, work with all sorts of workloads in the cloud, VMs, containers, serverless, and also it can secure the whole life cycle of an application, starting with the development phase all the way to runtime, and secure all the APIs and do posture on our cloud environment. And one differentiator is actually implement this what we call attack path analysis. So when we throw those vulnerabilities to our developers, a lot of time it doesn't mean anything to them, right? So what is the context of those vulnerabilities? Then if we can tell them how does the bad guys leverage certain vulnerability, or maybe you have over permissive configuration on your cloud, how can the bad guy access from the public, from any IP address to your workload and get access to your critical assets? Then it will help them understand, right? So Panoptica can, through that, we can show them the whole entire attack path. The bad guys can access my EC2 instance and get that administrative access, and we can remediate that as well. So you can download that Terraform script or run a AWS CLI or any cloud CLI, and then you can remediate that. And we can summarize all of those attack paths and show you, hey, you have administrative access that the bad guys can gain from all of these different attack paths. And then you can address all of these attack paths by just running that remediation script, right? So and then we can also do posture and code, and integrate with CI/CD and all of those capabilities. I'll introduce the API as well. Now we have a pretty good documentation on Panoptica's API. Right now is version 2.0. So I have the link there, and also the link is also built into the lab so that you can interact with Panoptica here, and you can use different languages as well. So pretty easy to work with. And the lab itself is on cs.co/appsec. And when you access this link, it's going to take you directly to our API security lab. And we have some introductions built into it. Now, some overview of our application security. And the first module is secure workload, and the second module is Panoptica. So the secure workload module is pretty easy to follow. And when you start learning, and of course, again, here you need to log in either with CCO or maybe Google or GitHub. You can use any account to log in to our environment. And when the environment is up, you will have instructions on the left side, and there's an editor on the top right to help edit any file in the environment. And at the bottom, there is a terminal, which is a container that you can use to interact with the lab. So we'll not go through the lab together, but everything is just click through. So I intentionally exposed the code, so if the attendee want to run this lab in their own environment, they can just use the same GitHub link and access the code and run it. And we'll introduce the the Titration Pi client. This is the SDK, the client that we're going to leverage to interact with a secure workload. But the whole lab is very easy to follow. Basically just click through, and we're going to be building a code together. And I have warning signs to make sure that the attendees are accessing the right file. And when they edit those files, they don't have to actually type anything. So all they have to do is basically, let's say, for example, if I want to run one of these, this is a test one, and you just have to click on that button, and then it copy and paste that into the bottom of the file. So basically, you can just click through the whole lab. You don't have to get to the bottom or anything. Just click through, and then so it's very easy to follow. So the gotchas here would be towards the end of the lab, after we've built the whole script. Then when we are outputting all the vulnerabilities that we saw from the lab, then there could be some 500 errors that are listed here. So you can ignore them. Sometimes in the lab, because it's a shared lab, sometimes in the lab there could be some situations happening that there could be one or two 500, but the whole output should work. Just ignore the 500. That should be all right. And like I said, I have a whole demo of the secure workload UI and all that in a video at the bottom of the lab. So that very quickly, that's the secure workload lab. And then the next section is the Panoptica lab. And this is where we are introducing Panoptica. So one difference here is that the attendees will get their own Panoptica account. So they basically just right click on this link and open in a new tab. I usually would suggest run a private window or a incognito window. So if they already have CCO, we don't want to mess up with that, right? So we want them to not use any existing cookies or anything. So that just make it smoother. So, and then after that, you just sign up as a user in that Panoptica UI, and then you will have access to the Panoptica dashboard. So the first thing that we're going to do is we're going to start that integration of this lab to our Panoptica environment. So within this lab, we're simulating a whole Kubernetes environment, right? We have a whole Kubernetes cluster here, and that's done by kind, right? So we can get, like, we simulated a whole cluster here, and that we're going to use, and we're going to deploy a application in this cluster, and then we're going to deploy Panoptica, and we're going to use Panoptica to secure the application. So basically, just follow through the steps. You are creating a Kubernetes account, and that's going to give you, you need to tick that API security button because we're going to also do API security. We can leave the cloud detection and response, name it, and then you will have a Helm script here. Now all you have to do is copy that, and then you paste it in the environment in the terminal here, and that's going to deploy Panoptica controller into this environment. And after that's done, so I have the example output here. So it should deploy the whole environment, and the API controller is also deployed, and then this is the correct output. And then we're going to get into API security, because this API security require another component, which is called trace sources. And with the trace source, we're gonna need a API tool, a CLI tool. So the users need to get the access key and the security key from that Panoptica UI, and then they need to put it in here, and then we can run a script here to pull down the trace source. So the trace source, we support, Panoptica support Istio, which is our service mesh, right? That basically deploy a Envoy proxy next to each of the containers that secure them. But we can also support like API gateways like Con and Nginx. So that provides that north-south visibility. But if we use Istio, we can see the east-west communication among the containers as well. So that gives us the best visibility. So in this lab, we're going to use Istio, and we're going to deploy our API security trace analyzer. So it's called a trace filter that injects into Istio. So now we can see all the communication among all of those containers, okay? So that's that piece. And then this is the fun part. We're going to deploy a cloud native application called Sockshop. So one click of a button, we can deploy that application. That application is going to spin up, and we're going to see how that application spins up here, how many different components it has, and whether it's running. So we're creating that containers, and then after about 4 minutes, the whole thing spins up, and then we're going to spit out the link to that to this application, and then you can access the application, and then you can play with it as well. But we're going to have a script that simulate users who are accessing that application. So one click of a button, we're going to download that script, and it's going to run and simulate a lot of clicks, so we can have a lot of API data. And then we're going to view all of that on Panoptica, so we can see all the API calls, and right away we are identifying security findings for these API calls, right? So so the users can explore all of those findings, and we can also see the attack paths that we're able to identify, and the users can explore those different attack paths as well, see how we identify those, your application, how a bad guy can access it from outside, right? So lots of great examples that the users can explore, and they can also see the security posture that's done by Panoptica as well. So all the resources, are here. So we have the documentation to it, and also the API documentation, and also we have a summary, section that summarize all of these different labs. So that's a quick overview of the application security lab. Any question?
No, that was great. Like I haven't done that Panoptica lab, but now I want to go do it because it actually looks like a lot of fun.
Oh yeah, yeah. It's very hands-on. So you might need a little bit more than 30 minutes, but the good thing is